Good evening all. So today we'll discuss about logistics regression. So basically it's a supervised learning mechanism and generally it is used for any type of classification task. Okay. So sometime we might have seen that maybe we need to filter among whether an email is a spam or any specific type of tumor in the healthcare industry, it becomes a malignant. So for that purpose, we generally make use of this statistical process, which is known as logistics regression. So here also, like simple regression technique, we start finding or exploring the relationship among the independent variables and dependent binary variables at the same point of time. So generally, there are various applications of logistics regressions, just like if you consider an education sector, whether you'd like to predict whether a student will get admission to an university program or not. At the same point of time, if we consider any specific type of business sector, there our main responsibility is to find out whether a credit card transaction is a fraudulent or not. So there are several usage of logistics regression. And as I already told you, that it's actually a supervised learning mechanisms. Let's have a look on a very important uh, diagram which is related with the logistics regression, which will explain the concepts I'm talking about. So if you just have a look on this particular diagram, you might have seen that there are input like x1, x2, and x3, and ultimately it's helping us to take a specific decision like happy or sad. So in any decision support system, basically we can make use of logistics regression. So generally, whenever you are talking about any enterprise environment, just like I told you in Gmail, we make use of the filtering options that whether a specific email is a genuine or it should go to a spam folder. So that can be actually decided with the help of logistics regression. So there are a lot of applications, as I already told you, which can be implemented using logistics regression. But the most important thing which we need to understand over here is sigmoid function. It's a mathematical function generally used for the visualization. And generally here we make use of one threshold point while talking about a specific logistics regression, and anything the value goes above the threshold can be treated as 1 and value below that generally treated as 0. So just have a look on this particular graph. It's also known as S-curve. Okay, because of the nature of this particular graph, the sigmoid function is also known as S-curve, and you can see very clearly that at 0.5, which is the threshold over and above, we can treat the value as 1, or else below that, the value generally treated as 0. So that's actually the main criteria for logistics regression, and the problem which are aligned in this particular scenario can be treated with the help of logistics regression analysis. Let's have a look on what are the different categories of logistics regression. So generally there are three specific categories as we have seen over here: binomial, multinomial, and ordinal. So suppose if you like to just predict the value of the dependent variables as 0 or 1, or it can be pass or fail respectively. So we can say it's a binomial logistics regression. Whether for multinomial, we can say that there can be more than two values, like as you have seen in this specific example, there can be three different categories we have considered over here. So this is basically an example of a multinomial regression where we can have all unordered type of various dependent variables and represent it in the following way. At the same point of time, it can be an ordinal, like say, for example, we can have three possibilities like low, medium, or high. So if you consider an examination grading system, so where we have various types of grades awarded to the students, so we can go ahead and make use of ordinal logistics regression over there. So this is really important to understand that which is the correct situation for making use of different categories of logistics regression. And based on that, we can make use of it. Like say, for example, if you are considering about the disease prediction, so there might be three categories of disease, and we can make use of multinomial logistics regression to predict the possibilities based on our analysis, as well as the kind of model basically we will use over here to predict the proper disease, which is obviously coming in an unordered ways, isn't it? So that's three different categories, and we can use in various purpose: binomial, followed by that multinomial, and ordinal logistics regression. So if you do a very rigorous comparison, a comparative analysis between linear and logistics regression, so we can say that linear regression is basically used for predicting the continuous dependent variable, where an independent set of variable has already been given. Whereas for logistic regression, exclusively is used for the categorical variable, isn't it? At the same point of time, we can also say that there is a close relationship between linear and logistics regression, because the concept of linear regression is also used for solving any kind of logistics regression problem. At the same point of time, any specific type of classification related problem in machine learning can be solved with the help of logistics regression. So in linear regression, basically we talk about the model, and here generally we consider the best fit model, as we know that there are underfitting and overfitting model, but we generally focus on the best fit model associated with the linear regression strategies, where logistics regression is basically depicted with the help of an S-curve. There are various mechanisms we also use to select a particular model with the help of its accuracy. So there are methods like least square estimation, which is used for the linear regression. Whereas if you consider the maximum likelihood estimation is one of the methods basically used for the logistics regression. So both are very, very important methodologies we use in machine learning for various categories of predictions. And there are certain assumptions always made in logistics regressions, like independent observations, binary dependent variables, to find out the linear relationship among dependent and independent variable, provided there is no outlier. And always we keep considering a very large sample size of data set while working with any logistics regression. So this is a certain thing always we have to keep in mind while working with the logistics regression. There are certain rigorous technical steps being followed over here, like first understanding the problem and define it in a proper way. A rigorous data preparation has been taken care over here, like removing the duplicates as well as the null value, followed by that an exclusive EDA or exploratory data analytics being carried on to visualize the data and the relationship among the dependent and independent variable at the same point of time, and any specific type of anomalies could have been detected in this specific phase. Followed by that, selecting the right feature is really, really important, like among various independent variables which are really important, and providing a relationship among the dependent variable is really important in this particular regression strategies. Once that part is done, then we start focusing on building a specific model using various categories of coefficients linked with the corresponding independent variable. At the same point of time, evaluating a specific model is very important. We make use of accuracy, precisions. Recall, these are certain standard strategies basically used for evaluating a particular model, and followed by a rigorous refinement took place to improve that specific model. Once all those steps being done in a proper way, we go ahead with deploying that specific model. So this is basically the fundamental concepts of logistics regression, which should be very, very clear before we start working with any hands-on. Thank you so much.